having here John with us. He's going to be talking about the agile testing without automation. It's an interesting topic. And John has got a wealthy experience in testing and management. Let me welcome John.
Thank you, Jay. Welcome, everybody. Thank you for coming. I hope you're enjoying the conference. So we're going to talk about agile testing without automation, question mark. This talk will be specifically about how Puppet reduced its commitment to automated testing. And in the process, we discovered some interesting side effects. That we improved the velocity of our software throughput. We reduced our severe defect rate. We gained, as a QA organization, a better understanding of our product risk and of our coverage of that risk throughout our testing. We also improved our partnerships with the developers and the other members of our Scrum teams. So I'd like to, if you allow me, to define a couple of terms. These are all industry terms, but as with the nature of industry terms, we all have sort of a different understanding, so that there's no ambiguity between what I mean by these terms and what you might mean by these terms. I'll just take a couple of minutes to define these. The first is test automation, which I would define as the programmatic execution of a test run frequently in an integration system such as Jenkins or Bamboo or any other continuous integration system. So I want to focus on the word frequently in that definition. And by that I mean that it will occur on a predictable cadence. So continuous integration, depending on how it's implemented, may be a bit of a misnomer. It may indeed occur after every commit for a truly integrated testing paradigm, or it may occur less often, such as on nightly runs, weekly runs, a per-release run. No matter what that cadence is, if it occurs on a regular cadence, I would consider it an automated test. I'd also like to define the primary software development processes. First, waterfall as a sequential development process that gates the preceding step, on the preceding step being concluded before continuing on to the next. And the core steps being requirements gathering, design, implementation, and verification. So also I'd like to define agile specifically as the iterative development process focused on frequently delivering working software based on customer collaboration. So within the agile community, there is a framework called Scrum, which we use at Puppet. This is a framework where a team works in defined time-based ranges called sprints to deliver that working software that I talked about earlier. So Scrum also uses those sprints to capacity plan. So you'll start the sprint with a set number of story points that the team feels it can accomplish over the course of that sprint. Ideally, they would be structured in such a way that the team can continually be working those down to the point where all of the points are completed by the end of the sprint. With those in mind, I'd like to define the term, agile fall. Which is a conflation of waterfall and agile, and for all intents and purposes, it's really a process smell that means that you're doing agile wrong. But I don't want to put too fine a point on that, because we all work in complex organizations with varying needs. So even though we have many benefits when using agile, they give us a lot of flexibility, the ability to iterate on change very quickly, there are always going to be aspects of the organization that want more predictability out of the delivery, and to make sure that they can hit marketing concerns and deliver a product on time. So there's always going to be some pressure to sort of pair those two together. Hopefully you have a good balance. We're going to talk about how Puppet did not at one point. So with those defined, I'd like to tell you a little bit about Puppet. If you're not familiar with Puppet, It's a product that is an automation tool for deploying and managing software on a variety of platforms. So these platforms range from the majority of Linux variants to Windows servers, Windows desktops, other Unix flavors, AIX, Solaris, HPUX, down to networking devices such as Cisco, Huawei, Juniper switches. It is the goal of Puppet to be ubiquitous in the data center and to be able to manage your infrastructure from soup to nuts. It provides a domain-specific language where you can define resources to be managed in your infrastructure, modeling your infrastructure as code, and then using that to propagate across your infrastructure. It is really a force multiplier in the DevOps industry to allow sysadmins who, prior to the availability of these tools, could manage maybe up to a dozen machines. Tools like Puppet allow system administrators to manage hundreds of machines simultaneously because they're not managing the machines individually. They're classifying these machines on the roles that they need to play in their infrastructure, and they are deploying the management of those machines based on the code written in Puppet. So given the breadth of those platforms, Puppet currently supports about 80 different operating systems. And we certainly could not do that without some automation. So we have a vast supply of automated tests for the ecosystem of our products. We use Jenkins to run those tests, and our Jenkins individual runs number between 500 and 2,000 instances per day. We do Jenkins both unit level tests and system level tests. The system level tests that we run in Jenkins can range in execution time depending on the complexity of the product and the depth of the test suite from a couple of minutes to up to 7 hours. So there's a lot of automation going on for us to be able to validate our software ecosystem at Puppet. So in answer to the question, can you do agile testing without automation? I want to say categorically, no, you cannot. However, the focus of the talk and of the case study that I want to present today is very analogous to what Justin was talking about earlier in his talk, that we don't want to automate all of the things. We want to be very judicious about making sure that the tests that get entered into our continuous integration systems hold the highest value for the product, hold the highest value for the customer, and minimize the cost of ongoing tech debt and maintenance for the tests themselves and the integration systems as a whole. So with that in mind, I'd like to wind the clock back a couple of years to the fall of 2014, where Puppet as an organization was certainly practicing Agile Fall in the worst possible way. Our development teams were indeed using Scrum-based Agile. They were using it by themselves, and so the ancillary support teams were not involved in that process. UX, Docs, QA were truly engaged in a waterfall style engagement with those teams in support of them. So QA would get involved with the development teams and the product owners early on in a feature cycle to help flesh out the requirements gathering and produce comprehensive test plans for the feature that would be developed. Once that test plan was signed off by the various stakeholders, including the product manager and the lead developer for the project before it kicked off, we would then wait quite a while. So although the development teams were using the Scrum framework for their work, they had culturally, because they were not involving people that were testing it, they were not producing testable artifacts at the end of their sprints. So quite often, it wouldn't be until very late in the development cycle that the development teams were able to produce a testable artifact that QA could consume. So at the bottom of the waterfall, QA would come in. We would then automate all of the tests associated with our test plans for the feature. We would commit those to the CI system. We would run it against the product. We would see a variety of colors with regards to the test results, and then we would work through the process of iteratively working with the developers to get the bugs fixed and get those CI pipelines green so that we could release the product. So the takeaway from this is that we were adding large volumes of very comprehensive tests to our CI system during this point in time. So in the winter of 2014, the engineering leadership at Puppet reorganized the engineering teams as a whole, knowing that the Agile Fall methodology was not serving us or our customers as well as it should be. So at that point in time, the Scrum teams got embedded QA, they got embedded docs representation, they got embedded UX. So the entire team was then responsible, in a true Agile fashion, responsible for the quality, and responsible for the user experience, and responsible for making sure it was adequately documented for the customer. So kicking this off, though, it wasn't all sunshine and unicorns. The developers had already been doing this work and had developed a cadence where they were used to consuming the entire sprint for their development work and getting that code committed just in time to close all the tickets at the end of the sprint. So when they got QA resources, they were delighted. They would have some support in making sure that that was validated before they were able to close those tickets out. What that meant was that they had immediately jumped at structuring that in sort of a mini waterfall fashion, where they would do all the code, commit it, and then lob it over the wall for QA to do the validation, and then the cycle would rinse and repeat until they went green. So there were a couple of very negative side effects of this process. One was that, again, because the development teams had not established did not have the cultural muscle of being able to allow QA enough time to validate, that we got to the end of the sprint, they committed their code, there was certainly not enough time for QA to do that validation, and we had a large number of story points that were carrying over from sprint to sprint. The other downside was that there was a mismatch in expectations between the work that QA could do and the resources that were available to do that work. So at the time, our dev to QA ratio was about 7:1. So the QA embeds for those teams were serving multiple teams. You had a single QA person that was embedded in multiple teams, and those teams were now said, oh, we have a QA resource, well, you will validate all of the tickets. And this was just not possible. So we had to come up as a QA organization with a solution to be able to mitigate the amount of work that was given to us, that we could commit to the teams to make sure that we were successful as an organization. So we derived a framework for risk-driven QA. We wanted to make sure that the Scrum teams and the constituent components of those teams understood that QA was there to focus on customer value. We didn't care about some of the implementation tickets. We were there to make sure that we were validating and providing the voice of the customer to make sure that we would deliver a quality product. In order to do that, we needed an empirical metric to be able to communicate engagement and to be able to measure the impact that the work in flight for the Scrum teams would have on the customer. So we did this by defining an overall customer risk assessment for each and every ticket. They had very coarse metrics. There was high risk, medium risk, low risk. The overall risk assessment was derived from two different vectors, two different risk vectors. The first was a probability vector, which, as you could imagine, was the summation and analysis of how often a customer would be impacted by a particular bug or the introduction of a particular feature. The other vector was severity. What would be the impact to the customer for a given bug or a given new feature? So let me give you a combinatorial example sort of at either end of those spectrums. So if we had a regression that resulted in data loss or data corruption, that would be of the highest severity, even if its probability was extremely low. So therefore, it would get a very high risk assessment. Conversely, we might have something that was not severe at all. For example, mismatch of colors or misalignment of text on our web interface that certainly would have little to no impact on the functional usage of the product. But because of its frequency that the customer would be encountering it several times per session, over time it would erode the customer's confidence in the quality and integrity of our product. So it would receive, so we would give that a medium score. So there's if you're interested, the metrics table for this is in the paper for this particular talk. So once we determined what the overall risk assessment to the customer was for a particular issue, those risk assessments were then mapped specifically to engagement protocols for the team. So for a low risk, a ticket that was deemed to be of low customer risk, QA's engagement was 0. We then committed to no additional effort on that ticket. For a risk assessment of medium, QA was then responsible for manually validating that a bug has been fixed, or feature has been correctly implemented on one or more applicable operating systems. An overall risk assessment of high meant that QA would commit to having an automated test committed to the CI pipeline so that we could see that feature go green prior to closing the ticket. So I'll give you some concrete examples of each one of those. So at the high spectrum, any functional regression that we would have in the product would mean that we had a gap in our existing functional test suite. We want to fill that. That would be an escaped bug. It would get a high risk, and we would take care of adding additional automation to make sure that didn't happen again in the future. Likewise, any new features that were in flight that had specific user or customer functional expectations, we wanted to make sure that those were also appropriately tested in the automated framework as well. On the manual side, where there would be medium risk. Let me give you a specific example where we have something that was deemed to be medium risk because of its low chance of regression, although it had impact on the user. So one of our Ruby command line utilities prompts for user input. That user input is designed to accommodate a reasonable size set of data. In talking to the developers, they told me theoretically there should be no limit to this data set. So in order to adequately test that, I designed an automated test that, that dumped the entire contents of Herman Melville's Moby Dick into those text fields and ensured that the text, that after it was processed and written to disk, that the entire contents of that novel still existed at the end of the process. So obviously that's a very expensive test. The likelihood of regression was deemed to be very low because for that particular utility, that functionality was supplied by the Ruby libraries themselves, which we are not going to swap out anytime soon. So it would be foolish to commit that to our continuous integration pipeline. However, that's an example where an automated test was written strictly for the purpose of manually executing it against core operating systems that might reveal interesting behaviors on Ruby on different systems. For example, a CentOS Linux system theoretically might behave differently than an AIX system where the Ruby is cross-compiled, or on a Windows system. So those three systems would be the core targets for executing that automated test. When they pass, that test would simply be deleted, and that would be an example of manual execution. Also, we would also have your standard manual execution, where you have a defined set of functionality, and we would just walk through the process of walking through the shoes of our customers to vet that functionality and make sure that it worked appropriately for the user. On the low side, where we would determine that the risk was low enough that we would not engage at all, I'll give you a couple of examples. One would be a refactoring effort where the existing test suite should be adequate to cover any unforeseen modifications in behavior in the code base. Likewise, we would not engage in QA validation for for bleeding edge support of like an R&D platform. So very recently we introduced package provider support for VMware's Photon OS, I'm sorry, which is an interesting technology. It is certainly not part of our core OSs that we support for our customers, either on the enterprise side or on the open source side. So we deemed that at this point in time, there was no need for QA to provide any validation of the efforts for that OS. If that OS does become the next big thing, and our customers are interested in deploying that at scale, we will certainly then revisit the risk and add appropriate automation for that. So in order to make this framework successful, we needed to make sure that we were very diligent about making sure that the tests, both manual and automated that we did, were adding value for the customer, and that we were leveraging our partners on the Scrum teams and collaborating with them to make sure that they could assist us in getting this work done. So we worked with the product owners to make sure that the acceptance criteria were clear for issues in flight, to make sure that we understood how to validate those, ask them to provide any additional use cases if that was necessary for us to understand how to validate. And in the process, doing that up front, hopefully providing with the developers with enough information that there was no ambiguity about how to implement the feature. Likewise, we would collaborate intimately with the developers. They are our greatest asset. So we would work with them in a consulting capacity, educating them about how to use our automation test framework, both to execute the tests the existing tests in an ad hoc manner as they were going through and writing their code to make sure that there was no system regressions. Also to educate them about how to write their own tests so they could fill that gap as they discovered it during their development efforts. Occasionally there would be concern that there was not an appropriate level of detail for a given feature to be able to implement that on the developer side. We had a couple of missteps in both culturally and the complications of working with time zones, where we were working with our team in Europe. We had some low-level language features that were being developed. The developers went through developed those to the best of their understanding based on the specifications that were given to them, only to be told later by additional stakeholders that they didn't quite hit the mark. So obviously this is extremely expensive. The developer was very frustrated and actually came to QA and asked us to provide preemptive acceptance tests that would fail prior to them writing the code, so that we would collaborate together with the stakeholders on their behalf to make sure that we had enough detail about what they wanted the implementation to look like, that we could write acceptance tests that would fail until the appropriate code was written. We'd supply those to the developers, then providing them an example that they could replicate in the future without our input. This allowed them to succeed in meeting the stakeholders' requirements without any additional rework required at the end of the day. We also discovered that QA's job is really difficult. So in working with our developers, there's a knowledge delta. So the developers are extremely knowledgeable, but we discovered that when we were onboarding a couple of them, that it took twice as long to bring them up to speed on how to test our products because of the complexity of the systems requirements that we have. And it took that onboarding twice as long as it took to onboard them for actually writing code for the products. So part of that speaks to the complexity of our testing environment, for sure, but it also speaks to the vast systems knowledge that our QA professionals have to have in order to make sure that we are adequately vetting that product before it goes out the door. So with respect to adding tests that are valuable to the product, we would also consult with the developers to make sure that we weren't duplicating effort. So there was quite a few instances where a ticket was deemed to be high risk. QA was committed to making sure that was appropriate automated testing to validate that. We would sit down with the developers and review their unit tests and discover that, lo and behold, they did the job. That there was enough coverage at the unit level that no additional systems testing was required. Job done. So this gave us a better understanding of the overall risk profile that was being covered both from a unit test level and a systems testing level, and gave us better information about how to adequately cover those things throughout the course of the development cycle. As we're developing our own tests, we want to be really sensitive to the cost of the execution. We want to make sure that the tests that we're writing take as little time and as little resources on the system as they need to. There are times where that simply cannot be mitigated. You're going to have a long-running, very expensive test. When that happens, then we need to get together with the team and understand what is the appropriate cadence, to execute that expensive test. Does it need to be executed on a per commit basis? Can we defer that cost to a nightly run? Can we defer it to a weekly run? Does deferring it allow us to mitigate that cost while still providing adequate granularity of feedback to the developer and to the team at large when something doesn't go right? We also want to make sure that the dependencies that we're injecting for the test itself are as small as possible. One of the expenses incurred in managing and maintaining a continuous integration system is the spurious failures that are generated by the dependency graph of the things that are used to actually execute the tests, be that for individual tests or for the system as a whole. So we want to make sure that we're minimizing the amount of dependencies that we have. We also want to make sure that the output, both from a logging standpoint and from an error standpoint, that the tests that we're writing are providing enough detail that when we're triaging those, that it is fairly easy to see what went wrong, and so that we can quickly triage those and get them to the teams that need to address them. But throughout this process, we still want to make sure that we are advocating for the customer, that we are doing this on behalf of QA as a proxy for the voice of the customer. And to that end, there's, irregardless of the automation that was done, there was still a significant amount of manual testing that was happening for validating our products on a sprint-to-sprint basis. And doing that manual validation not only gave us the opportunity to prevent bloat in our CI system, it also gave us the opportunity to use those technologies as the customer would, which wound up allowing us to make sure that we were providing a great user experience for the customer. We had one product recently where it was passing all of its automated tests. But when you're making sure that computers are thumbs-upping code that's written for other computers, that won't necessarily always touch on the overall user experience, even if those are defined. This is just a very difficult thing to test. I don't know how many of you have been involved in usability testing previously, but it's not just a one-off, discrete, testable thing. You can have an entrance interview with somebody that has just started using a product for a few minutes, and they may have very high regard, very high expectations, and very high impression of the quality of that product. And an hour later, that may be a 180. The overall user experience of using that product may have degraded their confidence in the quality and integrity of the product. So allowing our QA professionals to sit down on a regular basis and sit in the shoes of the customer and work through our products allowed us, in this particular instance, to discover a number of user experience issues that needed to be mitigated before we would think about releasing this product. So it's helpful to continuously have both of those occurring. So I want to talk about the results after using this process for a little while. The result most germane to this particular talk is that prior to previous commits of testing to our continuous integration system, we were committing a lot fewer tests, but those tests were of higher value and of higher quality. We gained a better understanding of the overall product risk and how we were covering that because we were working intimately with the rest of the team to look at the unit test coverage. We understood our systems level test coverage, and we were gaining a better understanding of the user experience testing that was done through the manual testing that we did as well. We developed much better relationships with the developers. We worked together as a team. It was the team's goal at the end of the day. We've realized this, where the team was responsible for the quality and for getting the job done. To that end, the developers wound up over time switching their workflow so that they finished their development work days before the end of the sprint, which would give QA enough time to do the validation, both for, automated and manual. It also gave them the bandwidth to participate in that effort. So often we would have developers assisting us with writing those automated tests, with providing the manual validation to allow us to get that job done. Conversely, as I talked about before, we were assisting them with making sure that they had the appropriate information up front to make sure that there was not any wasted effort on their part and that they could work more effectively writing code at the beginning of the sprint. So the upshot of that was that we had a much higher throughput of tickets in the Scrum process. Because the whole team was working collaboratively, we were achieving the burn down rates of getting those tickets closed with minimal rollover from sprint to sprint. But one of the surprising effects that we saw was a dramatic reduction in our severe defects. So for the Puppet product itself, for the 4 releases prior to implementing the risk-driven QA process, we had been seeing severe defects for the product rise, not insubstantially over time. And in the release before we started this process, there was a total of 24 severe defects reported against the product. The release immediately following implementing this, that defect rate dropped to 3. And that level of defect rate maintained itself for several releases thereafter. So in conclusion, I just wanted to bring our experiences to the table and show you that as a result of not focusing solely on automation, but leveraging both automation and manual testing to make sure that we were working with our teams to meet the goals of the customer, that we were able to provide a better product with fewer additional tests in our CI system. So I thank you very much for your time, and I'd be happy to answer any questions that you might have. Sir in the back? Mm-hmm.
How have you worked that in the team so that everybody's got work throughout the whole sprint?
Yeah, so the question was, how do we work the workflow so that everybody has work throughout the sprint? So there's during the sprint planning, we will have active conversations. When I talk about the risk analysis, that's not just QA coming from on high. We have discussions about how that risk is applied. This impacts the planning for the workload. So once we've brought the tickets in, there's a discussion during planning about what the work impact looks like. So we will also add points to those tickets if QA has additional work that impacts the overall point load for that as well. And we'll have discussions at that planning session with the developers about how much time it's going to take us to validate individual tickets in flight, and we'll plan that accordingly. Likewise, if it doesn't occur there, it'll occur in the daily stand-up. Sometimes it doesn't happen until the developers have actually gotten into the thing that they discover they don't have enough information, and they'll ask us for assistance. But we try as much as possible during the planning process to make sure that we have a pretty good understanding of the workload that everybody has, and where a QA fits into that. So you'll have a different cadence of tickets that do not take a lot of time to complete, other tickets that take a lot of time to complete, and we try to make sure that everybody on the team understands what that completion rate looks like. Sir?
When you're planning, you're actually trying to prioritize, we're going to do this, these items here at the beginning of this, and these later on because of how that'll.
So it should, yeah, it's, normally not stacking it. Like one developer may have a couple of tickets that he knows are going to take a long time, and another developer may be taking on much smaller bits of work. And then QA can jump in and understand, like, okay, we can be adding assistance throughout that for the smaller ones, and if the larger work is of higher risk, we can be writing prototypes for the automated tests while that's in flight, so we can take the best use of our time. So it's a continuous conversation that we have. We take our best stab at it during planning, and then during the daily stand-ups, we'll be addressing those issues on an individual basis. Sure.
So can you paint a little picture on the process of moving from Agile Fall and how you got everyone on board to moving to this new process? And if there were any other alternatives that you looked at before deciding on this strategy?
Yeah, so the migration from Agile Fall to better Agile was sort of brought down on high by the engineering leadership at Puppet. The cultural change and the way that played out was really getting just working. It took some time, and we needed to first discover that we were at an impasse where QA simply did not have enough resources to meet the demand that the developers on the teams felt that they should be getting by this reorganization. So we didn't explore a lot of alternatives. We were just trying to figure out what is the tool that we can use to actively communicate with them, actively collaborate with them on a mutual understanding of how that would work. And so we proposed the risk-based system. We did a request for comments proposal outlining the risk-driven system, how it would work, what the matrix looked like for the combinations of those, what the engagement protocol looked like, and what we could commit to. So we outlined that entire thing in a document for the entire engineering team to review. The other aspect of it was to be able to constantly communicate that. So we had to make we use Jira for our issue tracking. So we had to add a number of fields to be able to track that information so that all of the stakeholders could see what the QA commitment was to tickets in flight at any given time. So in Jira, we added a QA tab that had both for each and every risk parameter, not only the value of the parameter, but the reasoning for that parameter. So if there were questions about, well, why did you come up with a high risk for this? I don't understand. There was a field that articulated exactly what that was for. It also allowed us to have more asynchronous conversations. If the developer had a different interpretation of risk based on their information, they could certainly contribute to that conversation. So given our focus on the customer, there may be risks that we were not affiliated with. The developer would say, well, due to the implementation, we have very high risk for this. We want to make sure that there's automation that deals with memory issues, these sorts of things. And then we would take that into account and raise and lower the risk appropriately in order to make sure that we were engaging properly to mitigate that risk. Thank you. Jeff?
So about the risk assignment just for that part of it. My experience with risk is that people are sort of binary on that, but they're threshold moves. So people feel nothing's risky except for this one thing. And somebody else might feel the complete opposite. Everything is high risk except for these couple of things I don't care about. So from the beginning of this process of risk-based QA to today, how have you sort of normalized that across the teams or kind of made it more consistent so that everyone has the same view of what is high risk and what is low risk?
So that comes from that's one of the benefits of breaking it up into two different vectors. It's not just sort of high risk, in the abstract.
Right. The impact and probability are separate. And they
Yeah,
get multiplied, but I mean, you could still, somebody who's really risk averse could game that to say everything is high risk.
So the team is reviewing those. So like as I said, because we're working as a team, like a sole stakeholder cannot simply declare something and the rest of the team be blind to that. So this is all done in the open. So it's open to challenge for people to say, well, I'd simply disagree with you with your assessment, and we need to revisit that.
And from one team to another, is it consistent? How the teams themselves, like in isolation, are they pretty?
That's a great question. I don't have empirical data on the breakdown. We certainly saw not a true normalization. It's not like a 30-30-30 split. It was kind of a bell curve where there, in rough numbers, there'd probably be like a 40-45% manual, and then equal low and high risk at either end. So there was a sort of a balloon of manual work that we didn't anticipate. So that was one of the side effects. So we wound up doing more manual work than we initially anticipated, because we had initially anticipated that there would be just a lot more low risk that would just drop off the table. But being very conscientious, it is difficult to say, oh, there's no risk there. But one of the benefits that we had to mitigating that was making sure the developers knew, even if QA was not going to commit to testing that, if they felt strongly about it, they could do it themselves. Either write that automation or perform that validation themselves. It was part of the educational process of making sure they had the tooling available to work through that risk on their own. Sir?
That's the last question we have. Yeah.
Okay.
I think you mentioned that when you were still in the waterfall or agile fall stage, there was a 7-to-1 developer to QA ratio. As part of the improvements that you implemented, did that ratio change?
I don't think it was a result of the improvements, but we've been actively trying to hire like crazy over the last 2 years. Our ratio is now about 4-to-1. So we can provide better support for those teams. We are not as thinly spread, and we can provide. We don't need to go as the risk curve. It can be more even because we now have the resources actually to do more testing than we did before. Thank you. Thank you, everyone.